The AXI protocol has a number of key features that are designed to improve bandwidth and latency for data transfers and transactions. Firstly, AXI supports two different sets of channels, one for write operations and one for read operations. Having two independent channel sets helps to improve the bandwidth performances of the interfaces, as read and write operations can happen at the same time. AXI allows for multiple outstanding addresses. This means that a master can issue transactions without waiting for earlier transactions to complete. This can improve system performance because it enables parallel processing of transactions. With AXI, there's no strict timing relationship between the address and data operations. This means that, for example, a master could issue a write address on the write address channel, but there's no time requirement for when the master has to provide the corresponding data to write on the write data channel. AXI also supports unaligned data transfers. For any burst that's made up of data transfers wider than 1 byte, the first byte's access must be aligned with a natural address boundary. For example, a 32-bit data packet that starts at a byte address of 0x1002 is not aligned to the natural 32-bit address boundary. Out-of-order transaction completion is possible with AXI. The AXI protocol includes transaction identifiers, and there's no restriction on the ordering of transactions with different identifier values. This means that a single physical port can support out-of-order transactions by acting as a number of logical ports, each of which handles its transactions in order. AXI supports a type of burst transaction called incremental, where the master only issues the starting address for the first transfer and implies that for every one of the following transfers, the address is incremented by the slave from the previous transfer address.